I will introduce the first presenter, Dr. Won-sang Lee. So, please welcome.
He just asked me to be here because he's filming me, so a bit like a, can you see me here? Right, okay. First of all, thank you for having me today for such a really important and interesting event. And I'm here to deliver some scientific messages to you about climate change. It's kind of like a quite scientific-oriented one, so probably some of you are not interested deeply. But anyway, my name is Won-sang Lee, working for Korea Polar Research Institute, and then I'm in charge of the unit of ice sheet and then sea level changes. Always the sea level changes. It was really complicated to remember this one. So I tried to do this one first. Alright. Okay, so mostly I would like to avoid the situations here. So actually, whenever I give a talk in the university or any other chances, then I saw very familiar with this kind of situation. But I really hope that you guys enjoy my presentations. But first of all, whenever I had such a conference or meetings about polar or the climate change, I frequently ask questions like this: what major difference between Arctic and Antarctica? And another one is that how much ice in the Greenland and the Antarctica? The third one is that is ice volume increasing? Or another questions will be global warming is really happening, and then instead of really rises in this current centuries. So first I'm going to start with the most notable difference between Arctic and Antarctica is that as you might imagine that the polar bears are living in Arctic only and penguins are living in Antarctica only. So that's the most notable difference between each other. The second one is that that one is the most important for me to understand what's the difference between each other. The Arctic region is that surrounded by continents. So actually it's an ocean, open ocean, and then covered by sea ice. And then the Antarctica, on the other hand, it's blocked by and it's surrounded by Pacific, Indian, and the Atlantic Oceans. So it's a kind of like continent. And then I think it's about up to 4,000 meters. Can you imagine how high is that? So it's covered by ice, and then it's continent. So it's quite like a different the regimes between each other. The second one is that how much ice in Greenland and Antarctica. So most of the more than 99% of the freshwater ice is existing as a form of ice in both Greenland and Antarctica. So it's a huge amount of ice is now frozen. And if you could imagine that everything melts from the Greenland or Antarctica, it gives us about more than 70 meter sea level rise at once. So it's a really huge amount of ice is frozen. And somebody just asked me that some researchers report that ice is increasing in some part of Antarctica. It's true, but as you can see here, that is the Antarctica. It's more like we can divide, if you imagine that this one is the Antarctica. In some part of the Antarctica, we call that East Antarctica. Then the rest of the Antarctica is West or Antarctic Peninsula. And then as you can see here, more or less East Antarctica is a bit like increasing, but the rest of the Antarctica is showing that the rapid ice melting or losing the ice. So overall, the ice in the Antarctica is definitely decreasing at this moment. And global warming, of course. So as you can see here, This one is at the seasonal difference here, and from pre-industrial level of the temperature, that is the zero, from the zero, and then from 1980s, somewhere here. That is the difference, and then the rate of the increase of the temperature. So recently, you can see that the difference is a bit like bigger than before, meaning that the increasing rates of the temperature is really fastly and sharply increasing recently. And then most importantly for us to see that, this is another map for showing that the difference of the temperature globally. And this warm and the cold temperature and the cold colors represent for the anomaly, meaning that the difference between the average from 1950 through 1980 and the difference between the average from this time period. As you can see here, is the current status. Now it's about like 2019. It's a bit more warmer than this one. So it's most strikingly to find this one is that the polar regions are much more warmer than the other places in the world. Meaning that even though we have about 1 or 1.5 degrees Celsius increased by compared to the pre-industrial level, the polar regions experience more severely than kind of like the warming situation than any other places in the world. And the next one is that the sea level really rising. Yes, it is. So this one is that observed by the satellite. It measures the height of the sea surface. So from here, it's kind of like a probably satellite era, and then these are observed by in situ. You get there, and then just like the measure the height of the sea surface. And as you can see here, it increases and abated until now, and then now it's a bit like it boosted strikingly again. The rate is really sharply increasing from about like 2015 or 14. So that's the real observation. And I'm going to start with my presentation and talk with the Anthropocene. Probably somebody you here heard about Anthropocene recently. So I'm going to show that first what is anthropo and then the scene. Anthropo means human. The scene, we can say that it's kind of like a new or recent. So people say that we are now already having entered into new era, epoch, called Anthropocene. This one is probably you could see that kind of picture or the graph in your probably geoscience textbook probably. The geologists categorized the Earth history from 4.6 billion years ago. Started from the Archean in Cambrian, probably Trilobite here, as you can see here, and then Jurassic, the dinosaurs everywhere in the world. And then now we're officially living in Holocene here. But as I mentioned earlier, some scientists or the people arguing that we are now living in a new era called Anthropocene, but it's not officially approved by the Geological Society yet. The thing is that we're now living in the Anthropocene, and then it probably started from 1950, and we are beneficial from kind of like a really new technology. So we are using electricity and then transportation and other stuff, really fancy things we're now using, and then it's really helpful for our daily lives. But the other part of the thing is that we dumped a lot of concretes and then microdust or microplastics, and then we're facing mass extinction, meaning that like we're losing biodiversity as well. And then these kinds of really like a pollution stuff or the other, this kind of not good things also at the same time we're facing. So these kinds of things like what brings us to our daily lives is kind of like an extreme events. It's a bit like a complicated figure, but I try to explain a bit like easy. So this one is the previous climate condition meaning that this is probably, you can assume that this is the mean temperature and then the variation of the distribution of the temperature. And this one is now shifted to a bit like a warmer, meaning that the average temperature is a bit like a warmer than before. So you may have more chances to have a bit warmer conditions. And then if the system is unstable, you have more variation, meaning that you have a bit like a wider distribution. So you can also have more chances to have extreme events, a bit more colder, a bit more warmer situation here. If you have both, now we're experiencing average temperature a bit like warmer and then varies a bit like wider, then you may have more chances to have extreme hotter and heat waves like this one. So it's really kind of statistically and theoretically approved that kind of thing. And then now in reality, we're facing kind of hurricanes or droughts or extremely cold temperature, and then also wildfire more frequently occurred in the California or Australia recently. And Category 4 or 5, which is really huge one, so it gives you really huge amount of damage to your daily lives. And then if this one is I haven't updated yet, but the thing is that the Hurricane Irma caused really huge damage into the United States. So many scientists or the people is really wondering that if it's really climate change caused or associated. Yes, it is. So actually, climate change boosted or accelerated or amplified that kind of extreme events. So it's really worried about it. And what I'm trying to say from now is that the IPCC probably is really important to have you guys to start with the 2019 SMCOP, because the COP are negotiating with the kind of based on scientific evidences reported by the IPCC. So recently, actually IPCC has been established back in 1988, and then they keeps publishing assessments reports based on the intensive reviews of the scientific evidences from 1990 to 2013. That's the latest one, and then the next one, IPCC AR6, will be reported 2021 or 22. So we have just kind of like a 6 or 7 year period between each other. So in between here, actually, as I mentioned and then I showed earlier, we are experiencing really sharp change, rapid change. So they feel they need to release another special report, kind of. I'll show you that later. But anyway, the IPCC. One of the most important contribution from the IPCC is that they define and identify this kind of warming is unequivocal, meaning that it's really happening. And then another really good point is that these kinds of climate change is caused by human, meaning that we're now experiencing and living in the Anthropocene, and then also we're responsible for that kind of climate change is the human-induced one. So probably you are aware that the kind of like a Nobel Prize was awarded to guys, Al Gore and then the president of the chairperson of the IPCC back in 2007 for their efforts to build up and then disseminate greater knowledge about man-made climate change. So officially and scientifically prove that these kinds of like all kinds of extreme events and the climate change is induced by human. So, as I mentioned earlier, in between AR5 and the 6, we need to feel the emergency and then promptness. So, they determined to publish some, so like 3 special reports, one for global warming of the 1.5 degrees Celsius, and then another one is for land, and then recently approved by 194, 6 countries approved unanimously. That one is that the ocean and cryosphere in the changing climate. So these 2 or plus 1 will be really intensively reviewed and then discussed by kind of like based on these kind of scientific evidences to upcoming COP held in Chile, Santiago. And then I'm going to just like focus on that, the special report for the ocean and cryosphere in the changing climates. Its volume is really huge, but like as you can see here, it's more than 1,000 pages. So if you want to, and then if you really want to integrate, and then it's really heavily and then intensive report. So you can understand this one. And then this one is really quick facts on this report. But like more than 100 authors involved to write this report, and then the gender equality is really key factors for the Sustainable Development Goal. And then, so we need to really mix and keep balanced with the gender equality. So more than 30% authors are women, and then from 36 countries. And in this report, about 7,000 papers, research papers were reviewed, and more than 3,000 comments fed into these report to improve the quality and then the robustness of this report. So it's really intensive work that's been done. So I brought just like two kinds of messages from this report in terms of like the polar and the ocean. This one is that the published in 2001 IPCC third assessment report. It's predicted about like 9 to 88 centimeters will be rising by 2100. And in the next volume reported and projected 59, and then goes up and goes up. That one is a recent IPCC report predicted that about like 1 meter will be rising by 2100. So what causes this kind of like the rising sea level? So mostly we didn't understand the dynamics of the Antarctica because we don't have any evidence of world observation. So it's really hard to predict or develop models to project the sea level rise in the future. So this one is the latest one, just a month ago, 2 months ago. Now it exists more than a meter. So by 2100, we will meet the change of the sea level by 1.1 meter, which is really, really huge. The difference between each other here and here. So what causes majorly contribute and contribute to this kind of like a big change here? They assess that the Western Antarctic ice sheet, meaning that the ice resides in the western part of the Antarctica, contributes hugely into that kind of sea level rise in the future. And then another one is that probably you can see here kind of like a storm surge. If you have a bit like a higher sea level, and then if you get some sort of like the typhoon or other extreme the storms, and then you have like an amplified some sort of like a storm or the other disasters into the urban coastal region. So this kind of like events will occur actually every 100 years. That's the previous projection. But the thing is that even though under all kinds of the greenhouse gas emissions scenario, meaning that RCP 2.6 through 8.5, all kinds of under the IPCC scenarios will meet that kind of event every year from 2050 to 2050. So it will be really, really dangerous situation we will meet because we need to have a bit like protections here, and then we need to move inward. Somewhere kind of like we need to have really proper mitigation or adaptation or the response plan according to that kind of the projection scenarios. So we try to, and then we would like to live in really kind of happy, and then we're pursuing to the sustainability development. Then kind of like the climate change is the most dangerous risks we are facing, and then it's really hard to predict as well. So as I mentioned earlier, again, UN determined about like 17 kinds of like development goals will be achieved by 2050. one of those is climate action. So we need to tackle the problems associated with the climate change. It's a really important factor. And then one of the grand challenges for the 21st century, again, climate change and the better projection of the climate change. And also, that kind of like economic forum, Davos forum, also determined one of the 10 global challenges for the 21st century. Again, we have environment and the resource security, meaning the ideas also associated with the climate change stuff. And this one is a bit like busy to see. This one is at the Davos forum, and then they are trying to quantify the risks. So if you can see, and then along this x-axis, these events will be more likely happen in the future. And then along this y-axis, these events will impact you a bit like more and more. And then seriously, it gets serious from here to here. So just in the middle of this graph, you can see here about like what was that? Territory attacks, meaning that like a war, and then food crisis, and then water crisis. It's just in the middle. And then as you can see here, most likely occur, and then it shows, and then we can imagine the most impact have is that extreme weather events, meaning that like hurricanes or the wildfire or something like that, as I showed earlier. So everyone now be determined and then recognize the kind of like climate change is really huge impact, and then immediately we need to tackle. So these like high-level people just like came together in Paris back in 2015, and then they made really ambitious goal, and they set really ambitious goal, and they committed to limit the temperature increase by 2100 by about like 2 degrees Celsius. Here is the UN target committed by the Paris Agreement, and then Tuvalu or the low-lying countries, they are really emergent, and then they keep saying that that's not enough. We need more challenging and then ambitious goal, which is that the 1.5 degrees Celsius. So the special report was published on this 1.5 degrees Celsius last year. So I will show that what's the difference between 2 degrees and then 1.5 degrees Celsius later. And to project and then to identify what causes this kind of like climate change, we need to track down the source of this climate change. The most of all, probably carbon dioxide is the one to contribute to the climate change. Also, again, methane or the other contributors also impacts a lot. But the thing is that the long observation history shows that the carbon dioxide that also unabated to increase from very early to here, and then this one is that the reconstructed by ice core, so we can track it back until 800,000 years ago. So actually, the ice core could capture this carbon dioxide, which indicates that what's environmental atmospheric situations back in about like 800,000 years ago. So these level about like 275 or below than 300 ppm is natural level of the carbon dioxide. But as you can see here, it now exceeds over 400. So it's really hard to get back here, meaning that it's irreversible change. So actually, nature should be natural like this, but really we doubt that these will be back down to this level. So it's really serious situation we're all now facing. So these kind of like a global warming or the extreme events and the climate change will affect sea level attacks by melting ice. So actually we're dealing with twice, which is just in Greenland first, and the other one is Antarctica. The Greenland has about like a 7-meter sea level rise contributor, But the thing is that the Antarctica is about 65 or something like that. The thing is that most like a rapid change in the Arctic is that sea ice melting, but the sea ice already floats in the ocean, so all meltdown of the sea ice could not contribute to the sea level rise. So we are now only focusing on the Antarctic ice sheet. As you can see here, this one is at the GRACE satellites, which measures the gravity. Gravity is really sensible for changing of the mass. So you're losing mass here, meaning that a lot of ice melts in this region. And then again here, we can call that here is in East Antarctica, and then this one is in West Antarctica. So this West Antarctica is experiencing rapid change of the ice melting in this region. And this one is that the contribution, the ice melts. Actually, Antarctica has lost a lot of ice loss, about like 3 trillion tons in 25 years. As you can see again, East Antarctica does contribute a lot, mostly from the West Antarctica. So strikingly, as you can see here again, from 2005 or 7, the curve changes sharply like this. So there are some sort of like contributors or some rapid changes occur somewhere in the West Antarctica has really big impacts on this kind of like a changing in this curve here. And the contribution, as you can see here, Antarctica, now they become the dominant player to contribute to the sea level rise in this region, in this world now. And West Antarctica, if you get all the West Antarctic ice lost, then all of a sudden sea level rise up to 6 meters. It's kind of like about 4 to 5 meters. So it's much higher than that kind of level. And then most importantly, East Antarctica is quite like stable, meaning that the melt rate is quite slow. But the thing is that the West Antarctica, as you showed before, this one is really unstable. So all of a sudden it just collapses. Then it gives you huge amount of like sea level rise at once. So it's really important to monitor in this region. So we are now working on this region at my institution, and then over the world as well. And as the sea level gets up, then most like a kind of major coastal cities, where is that? The San Francisco, in London, Shanghai, will be submerged. So by about like 2 meters, 3 meters, something like that. That has not been updated. So it's about like it will 400 years. It's not. It's about like 200 meters. The 200 years or 100 years. So sooner or later, you can see that these cities will be submerged. Sooner or later. So these charts and then graphs, it's really hard to realize that what's really happening in the real world. This one is occurring in Greenland, about 70-something minutes. It's just like a big collapse, meaning that the warm water penetrates underneath of the ice here, so keep melting. The ground underneath the ice, and then just like a collapse at once. But still, you don't get how big is that, the dimension-wise here. So one of my colleagues just like make really good comparison here. That is 1.6 kilometer within 75 minutes, about like 5 kilometers wide. It's really huge. And then that one is a kilometer deep. Still, you don't get that. How big is that? This one is a Golden Gate, 2 of those. It's really huge. And then this one is the Congress, the House. And then that kind of volume just collapsed. That's the real, really happening in the Greenland by the global warming now that we're facing. So it gets more worse and then serious. So you can find those kind of situations more often in the future. And this one is that that one is the Greenland, and this one is the Antarctica. Antarctica is normally much colder than Greenland because the average temperature in Antarctica in the summer season nowadays about like we are entering the summer season. It's about like minus 20, 0 to 20, and then winter season is about like minus 40 to minus 100. So it's really hard to see that kind of forming of the melt water up to the ice here. But these kind of like the surface melting, which likely occurring in the Greenland, but now we're also seeing those kind of like a tremendous melting in the Antarctica as well. And this one is a bit like a closer view. It's about like 20 meters, and then this one is about like 30 meters. So every second, there's about like 200 tons of the fresh water dumped into the ocean. It's a really huge amount of water. And if we pursue to the 1.5 degree, the bit like ambitious target, that is the RCP 2.6, and then this one is the RCP 8.5, which is the we just like emit greenhouse gases business as usual. And then this means that we just stop right now to emit carbon dioxide or the greenhouse gases. Then, even though 2100, it will be a bit like a stabilized, lower than 2 degrees Celsius. But we don't do anything, then will reach about like a 4 to 5 degrees Celsius. It gives really big difference between each other. So actually, the previous Prime Minister of the Tuvalu attended the COP21 Paris Agreement, and then he spoke that 1.0 and 2.0 is not enough to save themselves because the Tuvalu altitude is about like 1 meter or less than 2 meters. So if you get 50 centimeters or the 1 meter, then all kind of territory submerged. So no place to live in this country. It's a really difficult situation. And then probably you might think that if you get sea level rise of 1 meter, every year we have 3-point-something millimeter increasing every year. But the thing is that the increasing rate is all different because of currents or the atmospheric conditions. So interestingly, the Tuvalu, the severe situation they got, because even though we have the 3.2 average global sea level rise rate, but the thing is that it's about like 1.5 to 2 times they have than average sea level rise in this region. So it's really, really important to consider, and then we need to face that kind of situation right now. And then it's the most complicated picture on my slides here. Then the simple message is that this one is that the Shanghai or New York or Amsterdam, they are rich, so they have that kind of like a, it's really safe, the real danger. So even though scenario 2.5, 6, and then 8.5, they're really safe. But the thing is that the Tuvalu or something like that, even though they don't have enough money or the resources to protect or mitigate the climate change related problems, it's really hard to preserve their territory. So most vulnerable regions are just kind of like a low-lying countries or a bit like a developing countries. So we need to consider and keep in mind on this kind of like evidence here. Then actually the gas emission mostly comes from China, Korea, Japan, and then India, Europe, United States. But the thing is that these kinds of like gas emissions or the things will have to hurt those countries around here. It's not fair, right? So we need to feel the responsibility to kind of the low-lying countries. And probably it's the last slides of my presentation. We already know it. Why is that? I brought this one from my daughter. She is a first grader And then she's now like reading the book here. So if you just like feel uncomfortable or inconvenient, then we will make change to the green, or we will improve our environment. And then these are detailed action items. So kind of like you need to finish your food, and then underwear, layer the structure, buy like clothing, and then recycling, and then just like walk or ride bicycle, something like that. We all know that, but the thing is that we don't do that because we've already spoiled by the really convenient situations. So again, if we do the actions just mentioned before, we can live with that kind of safe situation, not here, right? So the message from the IPCC special report say that the time for action is now. And we keep saying that. We provide really robust and then scientifically approved evidences to the policymakers. But the thing is that we do not act because that we feel that we have enough time to protect or mitigate or face or tackle the problem. But it is not. So this is my last slide. So it gives you some like a really interesting message that what it looks like. It's kind of like the iceberg. Right? But the thing is that the flip over the plastic bag. So we dumped a lot, and then kind of like it's such kind of climate change or the global warming or the extreme events all depends on the human activities. So we feel really responsible for that kind of events or bad things. So we, like grown-ups, also like feel really sorry about that. So we need to also act together. So that's my last slides. Thank you.
We have 10 more time, so it's time to Q&A. So if you have any question, feel free to answer. Not answer. Maybe question. Yes.
Thank you for your presentation. I'm Ryan from National University. I have two questions. One, I wanted to know your opinion about geoengineering, because like my readings sometimes tell me that sometimes it can be very dangerous since we are not experienced enough and we might make things worse. And the other argument would be why spend money on geoengineering when we can actually combat climate change. My second question is regarding, a couple of days ago I read this new article coming out in Nature magazine about the new projections of sea level rise, which the part of South Korea should have Incheon, and I think some part of Incheon University is going to go underwater during the high tide. I'm wondering, in Korean Polar Research Institute that you're working, do they also work with other environment organizations in Korea to push countries in the United Nations Climate Change Conference to change their policies? Do you think they are involved, or regarding policymakers? Thank you.
Yeah, that's really important questions. Whenever I had such a really important and then probably answered question I got, then we just like go out and then back over here. So actually, the first question, so geoengineering. So we're really keen to get the thing involved into that kind of territory and then framework. So recently, probably you remember that the Nobel Chemistry Award, I guess, they invented the lithium batteries. So it just like help us to not using the fossil fuels as well, and then it also like helps us to kind of like develop more portable devices. So we need to develop and then pour more money to invest to have kind of like renewable, it's kind of like the solar or the hydro plants, something like that. So that's the one option. Then geoengineering is really hard to tell because as you know that the CCS, carbon capture and sequestration, is really Korea. Actually, I would say that is the top edge technology we have. So, but the thing is that there are some stages, meaning that developing technology to capture the carbon, and then where to put them into somewhere. Then we need to site survey underneath the ocean or underneath the kind of like a thick layer. So the site characterization is another thing. So these kind of like old technologies will come up with a really good solution to mitigate kind of carbon, something like that. That's the one point I know. And the another point is that as I mentioned earlier, the ice melts really rapidly occur in the Antarctica. So some of the scientists really seriously thinking that how to stop it. So 3 of drivers to accelerate the change of the ice or the melts of the ice is that fast moving the ice glacier. The other one is that this floating ice will stop the moving of the upstream glacier. And the third one is that the warm water intrusion. That these 3 drivers are key factors to accelerate the ice loss. So what they are suggesting or recommending is that because these really slippery, low elastic friction, because that if you have friction underneath, then you just imagine that in the rainy days, it's more chance to like fall apart. So you just like a dry underneath the ice, this first, because I like by drilling a hole and then just like pumping up the water underneath. The second one is that just you get built kind of like a bump, just be like another pinning point to resist and then hold the floating ice. And the third one is that you just like kind of like a really big kind of berm to protect warm water intrusion. That kind of the geoengineering idea is now conceptualized, and then they're really seriously thinking how to proceed. So, but the thing is that, as a point of the scientists, it's like a bit long journey to follow. And what's our activity to get engaged into the kind of like what was that, the projection and then the policymakers, right? So, I brought this slides. We don't have any actually action items solutions because like we are like this guy, right? So we just like identify and then do diagnosis, what's wrong and then what's happening and then what we can project. And then we just like give and provide valuable information to policymakers or engineers to solve this problem, right? So among scientific society in the America, they are saying that we have like a lot of evidence, robust evidence, what is going on, and then what kind of activity or actions should be followed. All the time we keep saying that to the government, our government as well. So what we are doing is that we keep publishing really nice papers based on the thoroughly validated or kind of really good evidence and observations. Then we need to get policymakers engaged. So last week, probably this one is as well in the course of the kind of action and then activity. So we need to have policymakers and then geoengineers or the other people engaged in kind of like this game. So we're not able to achieve the kind of grand climate change related problems. We need to get together and then act together. That's the only solution, and the act now is the most important message we can deliver.
Do you have any more questions? Yeah.
Okay.
You said about geoengineering as a solution to the reduce of greenhouse gas in the atmosphere. I read something that most experts and professors advise that the use of geoengineering can mean side effects or unexpected consequences. And I have a question of what kind
actually to answer because some of engineers involved in that kind of the industry, they're not happy to have my opinion because that the were project kind of byproducts or side effect by the geoengineering. The first one is that I'm not agreeing with the people already said, which is that the kind of, what was that, the geothermal stuff is kind of like a net climate change stuff, but the thing is that is the most prominent geoengineering activity in Korea. It triggers some sort of like the seismic activity, earthquakes, so people really worry about it, but the thing is that it's not fully understood, so geoengineering could mitigate or help us to just stop kind of like climate change. We are hoping for that. The thing is that at the same time, we scientists are now the numerical modeling to what is the side effect or the byproducts, and then we need to identify all possible elements will be affected or will be brought by kind of geoengineering. So engineering side, they're developing some sort of like the equipment or the technology. At the same time, we scientists were just like keep carefully monitoring the site, and also by numerical modeling, what will be next by kind of the activity of the geoengineering. So I feel like just reducing garbage or just by walk long distance is kind of like a passive or very small kind of contribution to tackling climate change related problems. The active action would be the geoengineering, I would say that. So that must be going forward, but the thing is that we need to consider what's kind of like a bad side effects caused by the geoengineering. So we're just like keep considering about it, but there isn't a solution what's really good or not at the moment.
It's time's up for the first session. So can you